I want to go over last week's Regents practice problem. It was a multiple choice question. So obviously on the real Regents exam, you would get 2 points if you gave a correct answer and 0 points if you didn't. Um, I want to make sure that you're not just guessing when you see these things. So I asked you to do a little bit of work. And so what I will do for grading this is I will give 1 point for the correct response and a second point for the quality of your explanation as to why the other three were wrong. Let's take a look at what the problem said. So we've got a definition of a quadrilateral. A quadrilateral must be a parallelogram if one pair of sides is parallel and one pair of angles is congruent. Two, one pair of sides is congruent and one pair of angles is congruent. Three, one pair of sides is both parallel and congruent. Or D, the diagonals are congruent. All right, so let's take a look at some quadrilaterals that are not parallelograms that satisfy a couple of the different descriptions here. For instance, let me draw an isosceles trapezoid. So an isosceles trapezoid is something with one pair of parallel sides and the other two sides aren't parallel, but they are congruent. Okay, so let's see how many of these different situations it satisfies. So does it have one pair of sides that are parallel and one pair of angles that are congruent? Yeah, so these two sides are parallel. And these two angles, for instance, are congruent. But this is not a parallelogram because the other sides aren't parallel. So 1 is not true, and that is an explanation of why. How about choice 2? One pair of sides is congruent and one pair of angles is congruent. Well, actually, that's true of this figure as well. So these two sides are parallel and these two angles are congruent, but still, this isn't a parallelogram still. And let's take a look at number 4. Number 4 says the diagonals are congruent. So let's think about the diagonals of this trapezoid. Do they have to be, are those diagonals also congruent? Yeah, they are. So once again, this figure is actually pulling triple duty. This in a isosceles trapezoid is not a parallelogram, but it matches the conditions of choice 1, choice 2, and choice 4. So that leaves us with choice 3, that a quadrilateral must be a parallelogram if one pair of sides is both parallel and congruent. Remember on our quadrilateral reference sheet, that was our choice right here. If we know that has a pair of sides that are both congruent and parallel, then if this is congruent to this and it's parallel to this, then let's draw a diagonal here. All right, so we've got this angle is congruent to this angle because they're alternate interior angles because of the mark of Zorro. And we also know that this side is congruent to this side because that's given. We also know this side that separates the two of them is congruent to itself by the reflexive property. So therefore, by SAS, we know that these two triangles are congruent to each other. Because notice, side, and the angle between them. This triangle, we've got a side, and the angle between them. So because of SAS, these two triangles are congruent, and therefore, we can say that this angle is congruent to this angle. And that means, once again, we've got a mark of Zorro backwards like this. So since those angles are congruent, these sides must be parallel as well. So knowing that one pair of sides is both congruent and parallel, we can prove that the other side is parallel as well. So that must be a parallelogram. You didn't need to prove that, obviously. You could just remember that this is one of the conditions for a quadrilateral to be a parallelogram. But in any event, I wanted you to come up with at least some explanation. And there are plenty of quadrilaterals, in addition to an isosceles trapezoid that are that match one or more of those conditions, but is not a parallelogram. So hopefully you can see the advantage of having access to a quadrilateral reference sheet and being able to at least come up with some of the ideas that are in here, because they do come up on the Regents exam.